Alright, welcome back. Let's get it started. Calculate the mass of copper deposited when a current of 0.5 ampere is passed through a solution of copper tetraoxide 6 for 1930 seconds. Given the molar mass of copper to be 64 and 1 Faraday constant to be 96,500 coulomb. So this is a typical UTM equation. Let's dive in and get our answer. Before we start, I'm going to give you a general formula for solving questions like this. So if you come across this kind of question, you can be able to answer it within seconds. All right, let's go. I'm going to break it down so you understand better. The formula is what? Mass in gram over molar mass equal to current times time over charge of the ion multiplied by the Faraday's what? Constant. So this is the formula for this particular what? Question. Now you have to bring down your parameters, right? Good. You have to put down your parameters and fix them and solve. Now our mass in gram is what we are looking for, right? They ask you to calculate the mass. So M is the unknown. Now you have your I current to be what? 0.5 what? Ampere. Now you have the time. They gave us time in seconds, which is 1930 seconds. Most times the time appears in hours. So if you have your time in hours, you convert it to what? To seconds. If you also have your time in minutes, you also convert it to seconds. So time should be in seconds. You know how to convert minutes to seconds? You multiply it by 60. Now from hour to seconds, you multiply it by what? 3,600. Now let's continue. So what again are we given? We have our molar mass. We have our molar mass to be 64. Then we have the Faraday's constant to be what? 96,500 coulomb. Now what about the charge? This is very, very important. Now how do you get the charge of the element given? You look at the element, you have copper. Now what is the charge of copper in this particular compound? The charge of copper in this particular compound is what? Is plus 2. That's what you're going to be using, 2. If you want to know more about charges of elements in a compound during electrolysis, let me know in the comment section and wait me for the next video. Alright, now for this particular compound, copper sulfate, copper is what? 2. In some compounds, the charge can change depending on the oxidation number. And another thing to consider is whether the element is a metal or a non-metal. So copper is a metal and you're going to take just the charge. But if it's a non-metal, you're going to give reference if it is diatomic in nature. These are the things I want you to know in my videos, so stay tuned. Let's continue with this. We have M, which is what we are looking for. Abi? Yes. Now, the molar mass is what? Equals to, the current is 0.5 by 1930. The charge is 2 times 12 and 6,500 coulomb, right? Good. At this juncture, you have to apply the knowledge of mathematics to this particular question. So we have this implies M over 64 equals half of this is what? 965. But you have 2 times 96,500. Do you know that this can cancel this? Yes, it's very, very possible. This can cancel this in the other side of the equation. Since it's an equation, right? We have 32 here. All right, this you cancel itself. Cancel, you have 100. So now, if you cross multiply, what do you have there? You have this, you multiply this you multiply this. You have this implies 100 M mass equal to 32. Divide both side by 100. Divide both side by what? 100. Therefore, M equals to what? 0.32 gram. This is your final answer. So look at this question. It is very, very simple. If you have this particular equation offhand, you can be able to answer questions relating to what? Electrolysis. Alright, someone out there needs this video. Please do it to share it with them. If there is any other topic you want us to discuss, let's see in the comment section. Enjoy your time learning as you wait for the next video.